Right, so this is another part of the alcohols topic, whether that be on the old specification, which was in Unit 2, whether that be on the specification that started in September 2015, which is in the organic unit. I think it's topic 5 in there, 3.3.5 or something. So anyway, making ethanol is the subject of this video. I'm going to get straight into it, not mess around. I want these videos, the new ones, to really stick about sort of 20 minutes ish would be quite good, sort of quite nice, easy amount. So making ethanol, there are two ways of doing it, or two particular ways that the exam wants to look at. One of those ways is via fermentation, and I will put these notes up on Google Drive and a link in the description. So fermentation, an equation for this then. So the reaction is basically, what we do is we're turning sugar, or glucose, C6H12O6, there's no reason that O should be so big either, it's just poor from me, into 2CO2, not as important, and 2CH3CH2OH, and this is our ethanol right here. So we're turning glucose, pen's a bit thick, glucose into ethanol, which is quite useful. How do we do it? Well, the process is done using yeast, and it's essentially the sort of it's the process that occurs really sort of in alcohol production. So if you were to do one of those sort of make your own brew kits at home, this is the kind of concept that you would use. And that actually leads us quite nicely into some of the conditions that are required. So I need to centre that up. So conditions that are required for this process. We've already got down the idea that yeast is required. So we need yeast, otherwise this is not going to happen. That catalyses this reaction. Yeast uses this in its respiration, but it's a particular type of respiration, and that respiration is anaerobic. Therefore, we need to make sure there is no O2 present, or air, but ultimately no oxygen present. Otherwise, this will undergo aerobic respiration, and that's not what we want. We want it to be anaerobic to allow for the production of the ethanol, which I guess really is, it's the yeast equivalent of our lactic acid, which does actually kill the yeast as well, which obviously isn't too good for it. A temperature. We're dealing with living organism, yeast, therefore it's enzymatic, it's an enzyme control reaction, therefore the temperature's got to remain fairly kind of constant, 40 degrees there. As humans, we need that 37-degree balance, and yes, we can live in hotter or colder conditions, but that core temperature, the homeostatic mechanism that keeps our core temperature around 37 degrees, same with yeast. If that changes, that 40 degree roughly, then enzymes are going to become denatured, stuff is going to go bad, and it's not going to end up very well at all. And that's basically fermentation done. I'm going to look at comparisons between this and the other process, which is hydration of ethene, but that's fermentation. This is our equation, producing carbon dioxide. Conditions, no oxygen required, and around about 40 degrees Celsius for that process. On the flip side, our other process, or other way of making ethanol, is the hydration of ethene. And again, start with an equation. We'll write it like this: CH2, CH2 or C2H4, either way. H2O in the format of steam, and that produces again our ethanol, CH3, CH2OH, or you could shorthand that to C2H5OH, is fine. No more shortened than that though, okay? That is either that's the ideal format, CH3, CH2OH is going to be good. Ethanol, ethene, that lovely alkene, and steam here. So how do we do this? Well, this is done using a phosphoric acid catalyst, and I should actually add in concentrated phosphoric acid around about 300 degrees Celsius and around about 60 atmospheres of pressure. I'm not sure whether that should be in capitals or not, but you get the point. So, bit of pressure, bit of heat, phosphoric acid catalyst, H3PO4, and we can turn ethene into ethanol by reacting it with steam. Now, luckily for you guys, and I'm sure you'll be over the moon by this has a mechanism with it. Now, I love a mechanism. They're the easiest ways, some of the easiest ways to get marks in exams. The mechanism is as such. It's an addition mechanism. I think it's electrolytic addition. We start with our ethene molecule, and what happens is that reacts with a hydrogen ion, and in doing so we produce an intermediate, a carbocation. Love that word, great. There's our carbocation right there. This positive carbon, it could be this one, doesn't really matter. In terms of making ethanol, it really doesn't matter at all. If in an exam they were looking at a different situation, bear in mind if you've got multiple chains, and in my dehydration video you'll see this, it's just the opposite really. If you've got if you've got more carbons there, you've got to watch for where things can attach to. So that's actually a key point to make. But we're looking at making ethanol, so we'll stick with that. But you could have to apply this to other situations. Next step, in comes our water molecule. Now I'm going to draw it with both lone pairs, but obviously only one is going to be used, and that's coming from the lone pair onto this carbocation here. What that's going to do is we're going to end up with this situation where carbon bonded to carbon, hydrogen with the oxygen attached. Note the oxygen now has a positive charge. Hydrogen's there. Final step is one of these cheeky little bonding pairs there and there are going to go onto the oxygen. Ultimately, I won't draw the product, but we can get what's going on here. Ultimately producing as our ethanol. We'll just be minus that there. So CH3, CH2, OH. Delightful. Remember, you've got to have this charge here. A few marks here for the mechanism's quite a nice one, I think, really. That's, in basic terms, the two ways of making ethanol. Now what I'm going to do is I'm going to do a nice little sort of table thing here. We're looking at kind of a few bits and pieces. I'm going to try and be clever and actually make it into a proper table. But we'll see if I'm actually able to. So they're going to look at the rate, quick comparison, quality of the products, the starter material, we'll call it raw material, starter material though, and the kind of process it is, and costs involved. Right, let's get a different colour here on the go. Let's have a look at drawing some lines. Oh, that's not really what I want. Let's try again. Nice. Nice. Oh, that is a dream. Okay. So, we're going to look at fermentation on this side. And hydration on the other. Okay, rate. I'm going to blitz through this slow, fast, impure, pure. So these would need to be distilled really. I will say need to be processed further. Distilled, yeah, distillation probably quite a good one. Raw material, sugars, process and costs. This is a batch process. This is what's classed as a continuous process. So what I mean by that is this one occurs in batches. It goes stop, sort it out, clear stuff, start again, meh, stop, sort it out, clear it again, start again, meh. So it occurs stop, start, stop, start, stop, start. In between that, you've obviously got to clear stuff out, you've got to redo all the rest, get your start materials ready and all the rest. Continuous means it just constantly occurs, and then we just take off this ethanol time and time and time again, whack more ethene in, make sure we've got plenty of steam, and the whole process is just blitzing along, reuse any of that ethene that we use up, just keeps going. That means that this one, low equipment costs. I mean, you can do this in your house, but high labour costs. Really, it's a bit of a pain one because of the fact that you've got to sort of be loading all this thing in and all the rest. Not really ideal. It's batch, continuous, high equipment costs. You know, you've got pressure and all the rest, and that temperature to maintain. You're not going to be able to do that in your back garden. But once it's running, actually, your labour costs are fairly low because it's, you know, it'd be more of an automated sort of system, just pumping stuff off here and there, boom, boom, boom. So, where to go from here? Well, there's a few ways that exam questions can then sort of like take some of these concepts and some of these ideas and change it slightly. And one of the ways is to be looking at the advantages and disadvantages of these two processes. Batch, obviously. Batch is potentially slow. We've got a low equipment cost and all the rest. Sugars. Now, a couple of advantages and disadvantages here. Sugars, advantage-wise, renewable. We can grow sugars again, no problem. However, on the flip side, what we've also got here is takes space for food. And what I'm talking about here is these sugars grown from plants. So I'm really kind of talking about as a biofuel, really, I guess. That's the key thing here. Ethanol is a biofuel. So sugar from plants, renewable, but takes space for food. Food prices increase. Neither of those two are particularly great, really. But then it is renewable. We can just constantly re-go with this. This, non-renewable. Crude oil, really, you know, it's not ideal. We're running out of it as it stands. To just use more and more of it's not really great. But then it is a continuous process. It's much quicker and all the rest. So it's a balancing game between, you know, the advantages and disadvantages. And in an exam situation, you wouldn't be expected to write an essay, but certainly up to a 6-mark answer on these various bits and pieces could be expected of you. So that's just a point to be aware of, the advantages and disadvantages that you can draw from this. But really, that's no different to GCSE, where you would have answered these similar kind of questions, obviously depending on exam board, but it's a very common topic, or it's a very sort of important topic at GCSE. I'm tying into that now. I'm going to do a couple of exam questions just to sort of highlight what you can get in an exam and sort of what you need to be answering and all of the rest. Alright, this is a question from June 2010. This is question 8, so it's right at the end of the paper. This was taken from, obviously, sort of what was now kind of becoming almost the legacy AS stuff. If you're resitting, then you'll still be doing that, but those starting the specifications straight from September 2015. These are now sort of old papers that old people did. But the stuff is still very valuable and still makes a lot of sense. And actually, the 8B here is going to tie into something that I forgot to mention in the theory section. But which I'll try and add into the notes there. But you'll see here. So glucose produced during photosynthesis in green plants is a renewable source of from which ethanol can be made. Ethanol is a liquid fuel used as a substitute for petrol. Blah 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 blah. You're given 3 processes. 1, photosynthesis in green plants. Yada yada yada. 2, fermentation of glucose to form ethanol. 3, complete combustion of ethanol. State 3 essential conditions for the fermentation of aqueous glucose in process 2. Write an equation for the reaction that takes place. Right, straight away I'm going to probably start with the equation. Nice one. C6H12O6 2 CO2 2 CH3 CH2OH. 3 essential conditions. Right, well, we looked at these. You've got yeast. Without yeast, this reaction's not going to happen. You have got 40 degrees Celsius, roughly, and you have got no O2. 1 mark, 2, 3, 4. How many marks is it out? 4 marks. Wow, look at that. That is literally the entire answer you need to write. That is just ridiculous. 4 marks. Bam, 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 bam. It took me about 2 seconds to write that. Okay, 8b. It has been claimed that there is no net carbon greenhouse gas emission to the atmosphere when ethanol made by process 2 is used as a fuel. State the term that is used to describe the fuels of this type. Now, I didn't actually cover this in the theory, and that was very naughty of me. But before we do anything else, I'm going to just write here, it's termed as carbon neutral. And as you would expect, it's neutral in terms of its carbon. Now, it says use equations 1, 2, and 3. So, what I am going to look at is this. In the production of glucose, we take in 6 carbon dioxide. So we are 6 carbon dioxides down. When we ferment our glucose to form ethanol, we give out 2 carbon dioxides. Okay, we give out 2 carbon dioxides. Then, when we combust a single molecule note of ethanol, we produce 2 more. Whereas, for every 1 glucose, we produce 2 ethanol. Each ethanol produces 2 of these. So we end up times 2 here, 2 CO2 here. So 6 in and 2 for 6 are given out. So in terms of what we could say here, so say the term that you use to describe fuels this type, carbon neutral. So basically carbon neutral just means that in terms of being applied to ethanol as a biofuel, it means that as it was grown, it means that the carbon dioxide, or the greenhouse gas, or the carbon, whatever you want to call it, that was taken in the growing process, when it is burned, that same amount, or in burned and produced, that same amount of carbon dioxide is released. So there's no net change. So no net change in CO2 or carbon emissions. Now in terms of what happens, equation 1, so process 1 produces 6 CO2, process 2 and 3, sorry that's wrong, take in 6, process 2 and 3 added together produce 6 CO2, therefore no net change in carbon dioxide or carbon emissions, and that's very, very important. So that's the question I wanted to look at on this paper. There is one other paper, and this is from January 2012, and it's question 9. So again, end of the paper, and that's what this one looks like. Right, I'm going to pick up the pace slightly on this one because we are running near the 20-minute mark, if not just over it. So reaction 1, we've got glucose becoming ethanol, we've got ethene becoming ethanol, we've got bromoethane becoming ethanol, and I want to look at all of these. I'm going to look at some of it. I like this first question in particular. Write an equation for reaction 1. Now, we've already looked at this equation for reaction 1, the idea of glucose becoming ethanol, so I don't really want to do that again. We can already do that. Write an equation for complete combustion of ethanol. Linking sort of the fuels topic, the idea here where we have the CH3, CH2OH plus O2, because it's a carbon and hydrogen containing fuel, complete combustion, we're going to produce carbon dioxide and water. Carbons 1, 2, so boom, multiply that up. Hydrogens 1, 3, 6, 4, 7, 6, 7, that should balance nicely. Now, explain why the ethanol produced with this process may not, I like this, may not be a carbon neutral fuel. Now this is 5 marks here. 5 marks! This is baffling. So equation for that, name the process, we can do that fermentation, C6H12O6 added to 2CO2 and 2C2H5OH. 2 marks there, 3 marks there, probably 2 marks here. Not sure where we're going to get 2 marks there from, but basically the idea is, the idea of it being carbon neutral it only takes into account the growing and the actual fermentation and the burning. It does not take into account the transport. So transportation of glucose and ethanol, in fact, requires burning of petrol, diesel, which produces, this is the key thing here, produces CO2. So this is unbalancing. Before we'd only taken into account the previous question, 6 was taken in, 6 was given out. But hold on, if every molecule of diesel or petrol that's burned, we've got another carbon dioxide going there. So we have unbalanced this whole process a little bit, which does therefore give us, well, we could claim that it's no longer carbon neutral. Right, let's look at the next question here. Not going to do that one, it's not to do with what I want to look at. Yeah, last one here. So this is tying into the hydration now of the ethene. So, boom to boom. Identify suitable catalyst. Conc, H3PO4. You could also have sulfuric, but the phosphoric is the preferred one. Identify the type of reaction. It's hydration. Or I think you can also have here electrophilic addition because we're starting with an alkene reacting to produce this alcohol. Give 2 conditions. 300 degrees Celsius. 60 atmospheres. 4 really easy marks for literally just this. Going to leave it there. Any problems, any comments, anything at all, stick it in the comments. Otherwise, I hope that's been of some help to you, and good luck.